All right, you guys, we're starting to learn how to factor. Now, the reason why I like this lesson so much is because factoring is, you know how when you were in elementary school and you learn how to add and then you've never stopped adding? Factoring is kind of one of those skills that we're going to learn it right now. And then you're going to do it again in grade 11, and then you're going to do it again in grade 12. And then if you ever take math in university, you're going to do it over and over again. It's literally like the adding and subtracting of high school. So it's a super important concept. I'm going to teach it very, very slowly. But that being said, I want you to know if you want to get good at it, you have to make sure you're doing your homework every single night. You want to make sure if you don't understand something, let me know, because the lesson I teach you the next day, it actually adds and builds on to the previous lesson. So it's very much like a concept that's built upon. So we start with the basics today, the easiest part today, then we'll learn something tomorrow, and we'll build upon it a little bit more and more and more. So it's one of those topics you don't want to fall behind on, because you will be very confused if you don't keep up with what we're doing. Okay, so take a look at that orange sheet. We're going to be, like I said, we're going to be factoring for maybe the whole week, like at least 4 or 5 days. And I'm going to refer back to this orange sheet every single time we start a new concept, because it kind of ties everything together. Right now, you're probably looking at it and you're like, nothing makes sense. All of these words are new to me. What is happening? That's totally fine. I don't expect you to know any of it because we haven't learned it. I'm going to start by talking about what exactly factoring is. And it's actually going to be, sorry, 1 second. I did have another. That's what I wanted to show you guys. Okay, so what exactly is factoring? Let me explain it this way. You know how we just learned that if you have two binomials, let's say I gave you something like x plus 1. By the way, you don't have to write this down. You can just watch, because it's not really a note. So let's say you had something like x plus 1 times x plus 3. We've just learned how to solve this yesterday. You're going to have your quiz on it. You know, to solve this, we're going to have to use FOIL. So we're going to go x times x is x squared. X times positive 3x is plus 3x. 1 times x is 1x. And then 1 times 3 is positive 3. And then I'm going to clean up the signs, and I'm going to get 4x plus 3. So this idea to go from here to here, this is called expanding. Because you're basically taking, like, kind of like, you know, distributive property. When you have a number outside the bracket, you multiply it and you're expanding it. So when you have two binomials and you're multiplying them, you're expanding. What is factoring? Factoring is basically, I'm going to give you the answer, and I'm going to ask you, what is the question? So you're going to be working backwards. In grade 9, you learn how to distribute. Now I'm going to give you the answer, and I'm going to ask you to go back and tell me what was the original question. So this is expanding, this is factoring. Let me give you one more example. And let's just go back to a grade 9 example. Let's say I had something like 2x squared plus 3. And I told you to expand this. Well, you use distributive property, right? You go 2 times x squared is 2x squared. 2 times positive 3 is plus 6. And so from here to here, you are expanding. Now, when I ask you to factor something, I'm going to be giving you, 1 second, I'm going to be giving you this, and I'm going to say factor this. And all that means is, if this is the answer, tell me what the original question was. So I want you to go backwards and factor it, and that's the idea. Sure. So in today's class, we're actually not going to get into the 2 terms, the 3 terms, 4 terms. We're just going to be focusing on this little box on the top right-hand corner. And that little box says, step number 1, factor out the greatest common factor if one exists. And then step number 2, we're not learning right now. So all we're going to be learning is that first step, something called a greatest common factor. Okay, so keep that in mind when I show you how to do that. And before we get into the actual factoring, I'm going to show you just some very easy examples to just help your brain understand what that means. Okay, what if I gave you a question like, I have the examples here. Okay. So greatest common factor. You can take this note if you want, or you can just watch. It's up to you. Well, let's say I gave you two numbers, the number 12 and the number 16. And I told you to tell me what is the greatest common factor. Now, you actually know how to do this because when you were in elementary school, you learned about factor trees, you learned about factors and all of that stuff. And so I just want to jog your memory and remind you how you did it when you were younger. So first, I'm going to look at all of the factors of 12. That is just a fancy word for you to tell me what are all the numbers that multiply to give me 12. So tell me the numbers that multiply to give me 12. You can just say them out loud. Anyone? 4, 6, and 2, 4, and 3, 1, and 12. Okay, good. So let's go ahead and write these in order. We said 1, we said 2, we said 3, we said 4, 4 times 3, then we did 6 times 2, and we did 12. Yeah. Like 6 is like a factor. Yeah. That's why we're only looking at them one at a time. So first I'm listing all the factors of 12. And now I'm going to do the same thing. I'm going to list all of the factors of 16. So we're not trying to mix them together. We're just looking at them one at a time. Let's do the same thing. Just tell me all the numbers that are factors of 16. Good. I heard 8 and 2, 4 and 4, 16 and 1. Okay, so let's list those. 1, 2, 3 is not, 4. So 4 times 4, 8 times 2, and then 16 times 1. Okay, now let's try to find all the common factors. That just means let's find the matching numbers between these. We have a 1 and a 1. We have a 2 and a 2. We have a 4 and a 4. Does everyone see that those are all of the common factors of 12? Yeah, but I'm not trying to ask you what the common factors are. I'm trying to ask you what is the greatest common factor. So I'm going to call that the GCF. You guys have your break already? Oh gosh, yeah, please back that. What is the greatest common factor between both of these? Good, and that would be the number 4. So when we're talking about the greatest common factor, basically what you're doing is you're examining the numbers I give you, and you're asking yourself, what is the largest number that is common between both of those multiplication tables? Now, we're not going to always write them down like this. We're going to get used to doing that in our head. But for now, let's just do another visual representation, and I'm going to give you an example with variables in it. Does anyone have any questions about that? Did it make sense? Okay, let me just pause. You can relax. Okay, so example number 2, let's say I gave you something like x to the power of 3 y squared and x squared y to the power of 1. So it's actually possible for you to find the greatest common factor between variables as well. 18 and 24. Okay, what's that? Oh, yeah, we're getting to it. Let's look at the factors of the first term, x to the power of 3, y to the power of 2. Here's how I do it, okay? This is the way I want you to visualize expression. Yep, Hershey? 3. So I'm just going to call them x and x and x. And how many y's do I have? 2. So I'm going to just say y and y. So this is just another way to write x cubed y squared. And then let's look at the second one, factors of x squared y. So how many x's do I have in, it's so slow, my goodness. Yeah, how many, I know you can't even see it. Okay, x squared y, how many x's do I have for this? 2, x, and how many y's do I have? Y, okay. So it's still the same idea. We're gonna see what we have in common. So I have one x in common here, I have another x in common here, x here, and then I have a y and a y in common there. So if I were to try to figure out what is the greatest common factor, what would I get? What's common between both of these? How many x's and how many y's? Safir? X squared and 1y. Good. The easiest way to do greatest common factor when you're dealing with variables is you just look at the number that is smaller. So here's the fast way. If I have x to the power of 3 and x to the power of 2, what is the smaller exponent? The 2, right? And then if I have y squared and y1, what is the smaller exponent? Y to the power of 1. So you just put those together and you would get the greatest common factor. One last example before we try some actual questions. How about if I gave you a question like this? So example number 3, I'll try to make it hard. A cubed, b to the power of 4, c to the power of 7, and a squared, b to the power of 5, c to the power of 4. And this time we're just going to try to figure it out without listing all the stuff. Because you guys are so loud, it's not going to work. Okay, so what do you guys think? What would be the greatest common factor for all of these different variables? Matisa, what do you think? Mithusha, what do you think? Good, and how did you figure that out? Yep, you're comparing them, and a squared is smaller than a cubed. Good. Perfect. Okay. So I'm going to stop there for a second. Okay, so now that we've done a couple of these examples, let's put it all together and try to see what greatest common factoring means. Sophia? Oh, you could just get really hot, but yeah, that's fine. If it's hard to see, I know. You know what? I apologize. You know, I'm going to try to use really dark markers for this. Okay, so let's say I give you a question like number 1, where it's 8x cubed minus 6x squared y squared plus 4x squared y. And I'm asking you to take out a greatest common factor. What this means is I've given you the answer, and I'm basically wanting a question where I have some sort of term and then another term in kind of like the opposite of what we learned in grade 9, where I gave you a distributive question. Now I give you the answer. I want you to tell me what the distributive question would be. Okay, so here's how I do this question. First, I look at all of my coefficients. We have an 8, we have a 6, and we have a 4. We awkwardly wait for it to come up on the screen. I don't know what that was. What is the greatest common factor between 8 and 6 and 4? So you're basically doing the activity we just did on top, but you're going to do it in your head. You're going to 6 and 4 and find the number that is common between all of them. That is the greatest common factor. So what do you think? I'm muted. Okay, 16. Does 16 go into 6? Not quite. In the Jeep? 24 would be the right answer. 2 is a common factor for sure, but it's actually the lowest common factor. In this case, the greatest common factor is going to be 24. Samara? So imagine me writing all the factors of 8, all the factors of 6, and all the factors of 4. Yeah, yeah. Yeah. The thing with 2 though is that, you know what? Hold on a second. Okay, so we're back. And actually, let me just show you the example and let's see if it makes sense. So in this case, the common factor between all of them would be the number 2. Really quickly, the reason for that is, let's say I have 8 and 6 and 4. The factors of 8 are like 1 and 8 and 4 and 2, and the factors of 6 are 1 and 6 and 3 and 2, and the factors of 4 are 1 and 4 and 2. And so what's common between all of them? It would be the number 2. So what I was doing before was the greatest common, but I was doing something way wrong. So the answer would be 2. Now let's look at our x's. We have x cubed, x squared, x squared. You pick the exponent that is the smallest, so you would pick x to the power of 2. And then we have no y here, a y squared and a y to the 1. Technically, that's like saying y to the power of 0. So what is the smallest exponent here? Yeah, y to the power of 0, which is just the number 1. You don't need to write that. So we're just going to not write that. We're going to keep it out of it. Okay, so now that I know my greatest common factor in this case is 2x squared, I'm going to see what I'm left with. So basically, I'm going to multiply 2x squared with a term over here, and I'm going to see if it gives me 8x cubed. So 2 times what number will give me 8? 4. X squared times what number is going to give me x cubed? X to the power of 1. Okay, so we took out our greatest common factor. We looked at the numbers 8, 6, and 4. We tried to see what was common between all of them, and we realized it's the number 2. We took that out, and then we looked at the x's, and we noticed that the smallest exponent is a 2. We looked at the y's, and we noticed the smallest exponent is a 0. We don't even need to write that. Now we're going to take the 2x squared, and we're going to multiply it to something here to give us the first term. We're going to do that for this next one. 2 times what number here is going to give me negative 6? Negative 3. X squared times what over here will give me x squared? Just a 1, right? X squared times 1 will give you x squared. We don't need to write that 1 down. And then 1 times what number here will give me y squared? I'll repeat that again. 1, let's imagine there's an imaginary 1 here. 1 times what number here will give me y squared? Did you try again? Try again. So 1 times what number here is going to end up giving me y squared? Think about it. I heard it. It's just going to be a y squared. Yeah. It'll just stay there. Yeah. Okay, let's keep going. 2 times what number over here is going to give me a positive 4, right? Positive 2, good. X squared times what number here will give me an x squared? Just a 1, we don't need to write that down. And then 1 times what number here will give me a y? Just a y. And that ends up being our final answer. And this is called factoring because we basically took an answer and we figured out what distributive question gave us that answer. If you wanted, excuse me, if you wanted to check your work, you could very easily check it by actually redistributing the 2x squared. 8x cubed. 2x squared times negative 3y squared, that'll give me negative 6 x squared y squared. And then 2x squared times 2y, and that's going to give me 4x squared y. And so that matches with our original question, which means we did the right thing. I apologize for that whole 24 in the beginning. I was actually finding something completely different, and it wasn't the common factor that we were looking at. This is going to take a little bit of practice. Like I said, we're going to do a bunch of examples. You'll do a million questions as well. So I'll take my time. We'll take our time and make sure we really understand this before moving forward. Question number 2 is actually easier than question number 1. We are going to, again, take out a greatest common factor. So I won't make the same mistake again. I'm going to look at the number 4, the number 2, and the number 8. And I'm looking at just the factors of it. So if I just go on the side over here, the factors of 4, the factors of 2, and the factors of 8, this would be a 1, a 2, and a 4. This would just be a 1 and a 2. The factors of 8 would be 1, 2, and 4 and 8, right? Because 8 times 1 is 8, 4 times 2 is 8, 2 times 1 is 2, 4 times 1 is 4, and 2 times 2 is 4. So what is the greatest common factor between these, Saran? It would be the number 2, exactly. So if you're ever confused, all you need to do is list all of the numbers that multiply to give you the numbers you're talking about. Just compare them and see what is common between all of them and what is biggest. The number 1 is also common, but it's not the largest one. So in this question, our greatest common factor is going to be the number 2. Is that fair? Okay, we'll do it together just so everyone can just take their time and try to figure it out. And then you can see if you're on the right track. All right, so I'm going to factor out the 2. That's my coefficient. Now let's look at our x's. We have x to the power of 3, x to the power of 2, and x to the power of 1. When you're trying to find the greatest common factor with letters, you look for the exponent that is the smallest. So what's the smallest exponent here? Jennifer? Just the x. Okay, great. So our greatest common factor that you factor out, you take out of the question is 2x. And now we need to see what is left in the question. So you're basically making a distributive question. You're going backwards. So 2 times what number here will give me a 4 as my answer? 2. X times what variable here will give me x to the power of 3 as my answer? X to the power of 2. Good. You're getting it. I'm glad. Okay, let's try the next one. 2 times what number here will just give me a 2 again? Sohan? Yep, I was going to write down the 1 just so I think maybe that might help you visualize it. So this is like saying 2 times 1 is 2, and then x times x is x squared. You don't need to write the 1 at all. I'm just kind of leaving there as a placeholder. 2 times what number here will give me negative 8? Yep. Negative 4. And then x times what number here will give me an x? Just the number 1, not an x, because x, yeah, just the number 1. We don't need to write that. That would be your final answer. Just to make sure, let's check our work, and you will absolutely not be required to check your work all the time, but it is a good way. If like you're done a test early or something, it's always good to just redistribute it and check to see if you got it right. So you, for all of these questions, you can actually always know if you have the right answer by distributing. So 2x times 2x squared is 4x to the power of 3. 2x times 1x is 2x squared. And 2x times negative 4 is negative 8x. So it seems like our question is correct. We'll just need to practice a lot. Okay, so the next type of common factor is called a binomial common factor. So take a look at the first question and ask yourself again, is there anything common between these terms? And when you look at them, you actually do notice that there is something that is common between this first term and the second term. What is common between both of them? Krushi? Yeah, do you notice that there's a W here and a W plus 1 here? Okay, now visualize this. If you wanted, you could, I wonder if that would help. Yeah, maybe, should I show you the substitution way? No, I'm not going to show you that way. I'm just going to get you to do the answer right away. Okay, so notice how W plus 1 is common between both of them. I am going to replace the W plus 1 with a letter. So let's say I replace the W plus 1 with the letter A. I'm going to show you 2 ways, and you can decide which way you really like to do this question. So now this is going to be like saying 4x times A plus 5y times A. So all I did was I replaced the W plus 1 with the letter A. So this is like 4x times A and then 5y times A. Sure, you could also put a bracket around the A if you wanted. So we can have 4xa plus 5ya. Okay, yeah, I actually like this. This might work. Okay, now if we were to take out a greatest common factor, just like we did before, you notice that the a's are the same, right? So I'm going to factor out the letter A, and I'm going to do the same thing we just did in the other examples. A times what number here is going to give me 4xa? What do you think? Yeah? Yeah, 4x. Does that make sense? A times 4x will give me 4x times a. That does not make sense. Really? It's just this times this is equal to this. You're literally just this term right here is like 4x multiplied by a. So if you factor out an a and you put the 4x and you multiply them, you end up with the original term. How about this part? What would it be here? A times what over here will give me 5y times a. 5y, positive 5y. And now, because we originally substituted the a for something else, we need to bring it back. So see where I have that a? What am I going to replace it back with? Yeah, so I'm going to bring back the w plus 1, and then this is going to be 4x plus 5y. Now, I often teach this a different way. I don't do the whole substitution thing, but I think maybe it'll be easier for you to visualize it this way. Some of you may be able to go directly from this step right to the, like you can go directly from here to here. If you can do that and you can see why you're doing that, then absolutely you can go ahead and do that. Does anyone see actually from the original question to the answer how you can go from there to there? If you can kind of start to use a little substitution method and try it that way. Yeah. Yeah. Well, so, okay, so this is the other way. Remember how I said I showed you two methods? Let me show you the other way. This is the more advanced way. So if you don't understand what's happening, I suggest don't use. Recognize that w plus 1 is common between both of these terms, right? Now I'm going to say, okay, w plus 1 times term over here will give me this first term. What do you think? The bracket w plus 1 times what term over here will give me that first term? 4x, yeah. It's going to come up in a second. Give it a sec. Oh, there we go. It's back. Okay. Now let's keep going and let's ask ourselves w plus 1 times what number here will give me 5yw plus 1 plus 5y. And then that's your answer. So that's a super easy way to do it. And if you understand how to do it, you can definitely do that. If you are not quite sure, then you can just do what I did, substitute it, and then factor, and then try it that way. Yeah. What's that? It didn't. You factored out the entire w plus 1 term. So like you factored it out, and now you're asking yourself what's left over. So it's kind of like in the previous questions, we factored out an x, and we saw what was left over. Brianna? Because see how in the original question, it's always kept in brackets? Like see how this is in brackets and that's in brackets? That's why I kept it in brackets. Because those terms go together. You can't just get rid of a bracket, so I keep them together. Samira? So yeah, fair enough. So let's try both of the methods again. So here we have question number 2. I'll first show you the substitution method. So again, I'm going to maybe let a different, so let's let the letter W equal A minus B. You can pick any number that you want. So now when I rewrite this, it's basically going to be 2x bracket W minus 3 bracket W. Just trying to see where I can fit that. Okay, does everyone get what I did there? I'm replacing the binomials, which I can see over here. This binomial and this binomial with the letter W. And now I rewrote it, so it's 2x times W. Okay, what is the common factor between these two terms? What's common between both of them? The letter W, so I'm going to factor it out. If you want to keep it in brackets, you can. And now I ask myself, W times what is going to give me 2xw? Did you? 2x. And then w times what over here will give me negative 3w. Negative 3. And then we need to bring back the w, which was, so it's going to be a subtract b bracket 2w minus 3. Oh yeah, why did I write w? Wait, why did I write w? Oh yeah, sorry. It should be 2x minus 3 and 2x minus 3. Yeah. Okay, let's do it the other way, which again is the short, however you want to think about it. You can recognize that both of these terms have a minus b in them. So I'm going to factor out the a minus b. And then I'm going to ask myself, a minus b times what term here will give me this first term? What do you guys think, Najib? 2x. And then a minus b times what over here will give me the second term? What's that? It's just going to be negative 3.
So would it always be like the numbers that are if for like for like
Yeah, that's basically the pattern.
so
No, we can't say always for any of them. It really depends on the question, but like that's one way to think about it. Question? I wrote a little helpful hint. It says we need to use both methods above to factor these. So I'm going to show you what that looks like. Okay, so question number 1 is AC plus BC plus AD plus BD. There is a lot going on here. Because you're factoring by grouping, what you're going to do is you're going to group the first 2 terms together, and you're going to group the second 2 terms together. Now, sadly, for these questions, it's not always going to work out that nicely. Sometimes you may have to group like the first and third together, the first and fourth, and just play around with it that way. I think for these questions, I did make it such that you didn't have to do that. You're just grouping the first 2 together and then the second 2 together. All right. Now what we're going to do is we are going to factor the first 2 terms. So do you see the first 2 terms are AC and BC? What is common between both of those terms? Krishna? Good. So I'm going to factor out the C. And what am I left with? So C times what is going to give me AC? You can just say that out loud. A. And then C times what over here will give me BC? I heard someone say it. It would just be a B. So this is like saying C times A is AC, C times B is BC. Shweta, you had a question? Guess and check. Yeah, so I know for a fact when you do your textbook questions, some of them, they'll be in an order where you're gonna like try the first 2 and then you won't notice it. And then maybe you'll try the first and the third one. So it's a little bit of guess and check. Letters, yeah, you're kind of looking for common, yeah. But really it's just guess and check. Now we're gonna do the same thing for the last 2 numbers, AD plus BD. What is common between both of those, right? The letter D. So Rain, what's going to be left in our brackets? Good job. Yep, you got it. If you can visually see that, if you can see what's happening, then you really understand what's going. Like that's good. That means you're really getting it. Now we're going to keep going. I'm going to answer your question 1 second. Let's do the same thing that we did before in the previous question. This is a binomial factor because A plus B and A plus B are exactly the same. So if I were to factor out the A plus B, what would I be left with? So A plus B times what over here is going to give me C A plus B? Yeah, does everyone see that? And if you don't see that, do you want to try the other method where you substitute? Because you can and see what you get. And then A plus B times what over here is going to give me this entire term. What's that? Positive D. So this is your answer. This is the question. This is the foiling question that when you do all the work, you end up getting this answer, and that's factoring. You're just working backwards, right? because it's not factored fully. Yep, sure. So this last step is actually exactly like this question here. So see how in this question, the what's in the bracket was the same? So what we did, I kind of did the quicker method, the second one I was showing you. So I noticed that a plus b and a plus b are the same. I factored those out and I asked myself, a plus b times what is going to give me c a plus b? And the answer is c. A plus b times what will give me d a plus b? And it's the letter D. Okay, just for this question, let's check it. So I want you to go ahead and refoil this and see what you get. So my check is just going to be, I'm going to take these numbers and I'm going to foil them. A times C is AC, A times D is AD, B times C is BC, and B times D is BD. And even though it's a different order, it's the exact same thing as the original question, which means that is the right answer. All right, you guys, last question. So what was the first step you did for this question? It's factoring by grouping. So you're going to group the numbers together. And I'm going to try to group the first two and the second two and see if it works. Like I said, it's a little bit of guess and check. It may not work. So when I group the first two together, what is common between the 2x and the 2y? Rain? Good. So I'm going to factor out the 2. And what am I going to be left with? X plus y. Yeah. How about the second two terms? What's common between both of those? Angelique? Good job. So 1x is common between both of them. Because remember, you look at x squared and x, the smaller exponent is x. You have a y and you have nothing, so you don't even need to include that. And now let us figure out what's left. So when you factor out the x, what are you going to have that's going to be left? X times what will give you x squared? X. X times what will give you xy? Plus y. What do you notice now? Yep, so the x plus y here and the x plus y here are the same. So now we're going to do the second thing that we learned, the binomial common factor. Okay, when I do that, what is common between both of these terms? The x plus y. So we're going to ask ourselves, x plus y times what is going to give me the first term? Amina, what's that? 2, yeah, and then x plus y times positive x is going to give me this term over here. Really an easy way to think about this, like a trick way is you take that and you take that and you put it there, and then whatever is left over goes in the second bracket. That's the easiest way to think about it, but I wanted to show it to you the proper way. Okay, how are we feeling about our first lesson on factoring? Do we feel kind of, or kind of getting it? Yeah, it's okay. Okay, we're going to spend a lot more time on this, like I said. When you go home today, I do want you to try handout B. There are a ton of questions. Just try your best, do as many of them as you can. I know I didn't give you a lot of class time because we had like half an hour less, but that's going to be your only homework. And then tomorrow's class, we'll start off with this. We'll probably take up like 5 or 6 questions, and then we'll do the next part.